DeepMind has re-entered the open source arena with its latest cutting-edge model, Gemma.
Gemma, it's easy.
These models, known as Gemma, are text-to-text decoder-only live language models. They come equipped with open weights, pre-trained variants, and instruction-tuned versions, making them highly adaptable for various text generation tasks such as question answering, summarization, reasoning, and code generation. Gemma is offered in two configurations, Gemma 2B and Gemma 7B. Notably, the Gemma 7B model outperforms the widely utilized Llama 2, 7B, and 3B model across all benchmarks, spanning general languages, understanding, reasoning, mathematics, and coding. But I don't know how much we can trust these benchmarks, as these benchmarks are done by Google, and seems like most of these companies are trying to present their models the best one. So I would take this as a grain of salt, to be honest, like this is the best model. In this video, we will be fine-tuning the Gemma model using QLORA and supervised fine-tuning. So let's get started. But before we do that, don't forget to like and subscribe, and let me know in the comments, have you tried this model? So the first thing that we need to do is to select the right runtime. So if you look at the session options here on the right, you can select accelerator and select GPU T4 X2, and then you can turn on GPU T4. Deploying instances of fine-tuned LLMs is very expensive. So we'll be using LoRa here. LoRa is nothing but low-rank adaptation, which is a fine-tuning method that freezes the pre-trained model parameters and introduces trainable rank decomposition metrics for each layer of the model. This significantly reduces the number of trainable parameters, making the fine-tuning process less expensive in terms of computation resources. LoRa achieves this by applying a low-rank approximation to the weighted update matrix. This means it represents the weight matrix as the product of two smaller metrics, significantly reducing the number of parameters needed to store the weight matrix. QLORA takes LoRa a step further by also quantizing the weights of the LoRa adapters to lower precision. So here we use 4 bits precision in place of 8 bits, thus the memory footprints and storage requirements are reduced further. Before we delve into the fine-tuning process, you will need to download the Gemma model. For that, Google has written a blog post. So we need to log into Gradle.com and go to the Gemma model card to request the access. From the drop-down on the right, I'm going to select the Gemma model. So there are multiple variations available for the Gemma model. So I'm going to select Gemma 2B. Generally, you will need a 800 GPU if you want to use Gemma 7B. So let's first check if the GPU is correctly detected. So I'm going to type NVIDIA SMI. So here I can see there are 2 GPUs here, T4 and T5. So that's good. So we are on the right track. Let's install all the Python packages that we will need. So the first one is Bits and Bytes. Bits and Bytes is a lightweight Python wrapper around code or custom functions, in particular 8-bit optimizers and matrix multiplication. So the next one is Transformer Reinforcement Learning Library. So it's a full-stack library that provides a set of tools to train transformer models. So it's still installing. Yeah, it takes a little bit of time on Gradle. Fast forward, I installed a bunch of libraries. PEFT is one of them. PEFT is just a parameter efficient fine-tuning library that needs to be installed. Then I also installed transformers, datasets, and accelerate. So I set up the Bits and Bytes config. Now I'm gonna log into my Hugging Face account. You'll need an access key for Hugging Face. You can get that access key from the Hugging Face webpage or clicking on the settings menu. Okay, we are logged in. Seems like the default Gradle model is a CPP version, but I needed the PyTorch version, so I went ahead and downloaded the PyTorch version from GitHub. You can see so we're gonna import the code now. So we'll need a Gemma for casual LM, a tokenizer, Gemma configs. So I'm importing all of these. It's time to load the model. So The new model that I'm using now is 7B. The reason being, Kaggle has 2 GPU machines, so you can easily use 7B. And you need to set the machine type as CUDA. I've seen that sometimes it is confusing in Kaggle to know the path. So you can just click on the model and it will show you the exact path. Here we are using Gemma Casual LM. It's an end-to-end Gemma model for casual language modeling. A casual language modeling predicts the next token based on the token either takes the raw text and converts it into vector that can be processed by the model. So
More data, more truth.
till now we use the CSV data for our dataset. Now I'm gonna use the core instructions style dataset. This dataset is available in Hugging Face. I'm going to use the load dataset function or the dataset library. Seems like it is throwing an exception here. I think I have seen this exception. It says file not found. It might be due to the version mismatch between the datasets package. After some debugging, I was able to identify the issue. So there was a version conflict in fs package. And now I installed it with a specific version and it's working. Okay, so the dataset is loaded in the dict. This is how the code instruction dataset looks like. In the left, you have the instructions, so like you can see the array, you have the string, and those, and then you have the text, and then you have the instruction like create a function to calculate the sum of the sequence of integers. So now we're gonna run the instruction fine-tuning. Instruction fine-tuning is just a form of fine-tuning where you provide a set of instructions to the model and fine-tune it on that. So there are 3 things that we need to do is to first use the function generate prompt that takes the instruction and output and generates a prompt based on the Gemma instruction format that they have provided. Then shuffle the dataset, and the third one is tokenize the data. So this is how the generate prompt function looks like. So here it calls this function, and then I shuffle the data set, and then the split is 80% for training and 20% for testing. And if you look at the output of the formatted function, so this is how the output looks like after formatting. So you have the text, you have the start of turn, you have the instruction, you have the input, you have the output, sequence, and the prompt. So we'll be using supervised fine-tuning trainer. It's used in the reinforcement learning human feedback. This is exactly what ChatGPT used in their code. So the idea here is to provide the prompts, and then there will be a labeler that will label it. The next step is fine-tuning. So we will be using QLORA here. We have already talked about QLORA, the lower rank adapters, using the get path model. So I'm going to prepare my model for Quebec training. This is how my model looks like for Gemma. So you can see there are different. So next you can see a bits and bytes function here that takes a PyTorch model as input and returns the name of modules that are instances of the bits and bytes linear 4-bit array. To create a LoRa model from a pre-trained transformer model, we import and set up LoRa config. So you can see here, for each layer to be trained, this is how the parameters look like, which is LoRa alpha, target modules, LoRa tuple. And the important parameter here is R, which is the rank of decomposition, and the task type, which is casual LM. You can have multiple task types, so you can have casual LM, feature extraction, question answers, sequence. Now we are ready to fine-tune. We are ready to fine-tune using QLORA. Now we'll be using SFT trainer, which we talked about a few seconds ago. And then, so I'm going to import the transformer, TRL. So the model that we created using the LoRa config, now it is ready to be fine-tuned. So we're going to be using QLORA. So for this tutorial, we are using SFT trainer from the TRL library, which we talked about a few seconds ago. I pass my model, the data set. And this is the transformer information. So all this is the training arguments for transformers architecture. And now let's load this. The trainer is set, the model is set. Now we're gonna just run the fine tuning or the training. This is gonna take, that is a lot of time. So I'm just gonna leave it running.
3 weeks later.
So the training is done. It took a long time. So here is the summary of the result. So you can see the number of steps were 100, and then the metrics for some of these. So I'm gonna call this model as a Gemma code instruct fine-tune model. And then let's save this pre-trained model. So I'm gonna have to save this using the save pre-trained function. Let's get the base model for Gemma. So I'm gonna use auto model for casual LM. Casual LM is nothing but the technique that is used by GPT-4, and it predicts the next token, unlike the mask LM. Now I'm gonna merge my fine-tuned adapters to the base model. So I'm gonna use the PEFT models dot from pre-trained. Oh man, finally we did it. Now it's time to test out the fine-tuned model. So I'm gonna just ask it to code the Fibonacci series in Python using recursion, and I'm gonna pass my merged model. Okay, it looks like the Fibonacci series is working well. So the code looks correct to me. It has printed a bunch of other information, but I think that is irrelevant to us. Overall, the code looks good. So based on the data that we provided to print in the code, seems like everything works well. That's all from our site. I will put the link of the notebook in the description so you can download from there. Yeah. And let me know in the comments if you have any questions or comments. And that's all from my side. Don't forget to like and subscribe, guys. And see you in the next